So this video, we will talk about the other instruction. That's the rotate. So we have the rotate. You can either rotate to the left or to the right. So when you hear about the rotate, that means we are not only go to the left or right, right? So there actually the open up bit, we were using the continue consider the whole byte is a whole. So that's why we will fill up the open up with the first rotation. So we see here, for example, how we do the rotate to the left. So that's why the same thing we see we're using the 1 byte example. So if we want to shift to the left, right, so we start from the most significant bit here. So you will see this one still the same thing. The first one we want to move, we will move to the carry flag. So then the rest of that, they just move up one by one. So before when we do the shift, right, we only shift. So that's why the last bit to shift to the left, they will be open up. But when we talk about rotation, that will be the same instruction like the shift. But this open up bit, they were using the rotation. Rotation by which one? By the first one. Because earlier you have the most significant bit. We only shift to the carry flag before, right? But now since we do the rotate, so this one not only copy over the value to the carry flag, and this one also go to the end. So that's why we can do the rotation. So that's why we call the rotate. Rotate shift each bit to the left when we do the ROL. The highest bit, actually the most significant bit, is copied into both carry flag and the open up the lowest bit. So that's why like earlier we say our shift, actually we have one bit actually not contained in the original operand. But rotation now, nothing lost because they come back to the end. So for example, if we have AL is the 1 byte like this, when we do the rotation, 1 bit to the left. So this one, actually they will leave, right? They will copy over to the carry flag. But when we do the rotation, this one also will go to the end. So that's why they become like this. So I can direct to give you a binary number, or I can give you a hex value. So when you do the hex value, you will see here, supposedly the hex value 1F. So the DL equal to, because 3, right? 3 is 2 and 1. So that's why it's 1, 1. Okay. So then F means all the 4 bit is 1. So then here, if we do the rotation, if we rotate every 4 bit, so then this one actually you will see you can rotate 4 bit, but also you will see this 4 bits when we rotate, right, they will become, because we do the 4, so that's why you will see the first 4 will rotate to the left. So then they become to the end. So then here you will see the last 4, they go to the front. So then the first beginning 4 go to the back. So then we actually find out, since the rotation have no bit left, no bit lost, right? So that's why here, if you do the rotation, no matter to the left or right, if you do the 4 bit, they kind of like, just like your hex, just rotate like this. So that's the rotation. So you have rotate to the left, of course you have rotate to the right. So we have ROR. So then you will rotate to the right. So since you rotate to the right, that means the least significant bit will copy over to the carry flag. And also this one will go to the most significant bit. So that's why we have no bit lost. Okay, so then you will see the example like the same thing. You can have 1 byte, binary 1 by 1. So we rotate to the right. Okay, so that's why actually it's this 0. They will move to here. So then each one go to the right. So then if you try to rotate, if every time you do the 4 bit, right? So you can consider they are hex. They're just using the hex to move each one. So rotation, nothing, no bit lost. So 3F become F3. So this one we have the rotate to the left and rotate to the right. But you will see here, actually carry flag just like a receiver here. To receive the first one, they want to copy over to the value to the carry flag. But that's just the first type rotation. Then if we want to rotate all the bits, including the carry flag, we do have the other 2 rotation. That we call RCL or RCR. So this RC means I rotate with my carry flag. So that's the C came from. So when I rotate with the carry flag, that's me. That's including the carry flag and do the rotation together. So that's why, for example, originally we have 1 byte here, right? So when we rotate to the left, the first bit go to the carry flag. But then this one, they are not going to the end. Actually, since we rotate, including the carry flag, actually the carry flag move to the end of the rotation. So you copy the carry flag to the least significant bit. So you copy the most significant bit to the carry flag. So when we do the RCL, actually we need to make sure how you will do your carry flag. So carry flag, we have one instruction we call CLC. So this means clear carry flag. That start the carry flag with a 0. So now if I have the BL is A8. So A8 in the hex, right? So when we do the binary, they look like this. So when you want to try to do the rotation, including the carry flag to the left, so that's why we need to be careful. Here is our BL, right? So we try to rotate to the left. So then you need to consider actually they will have this rotation together with the carry flag. So we rotate to the left. So then carry flag become 1. So this one will go to the end. So then they become 0, 0, 0, 1, 0, 0, 0, 1. So this one actually, 0, because your 0 will go to the end. So your 1 come here. So then you become 0, 0, 1 and 0, 0, 0. So that this one is the carry flag. So you will see here actually your rotation with the carry flag. Every time they also update the carry flag value. So that's why now the carry flag become 1. So if we do the RCL again with the 1 bit, so then they will do like this one. So is this most significant bit copy over to the carry flag? But then the carry flag actually will copy over to the last one. So that's why here the 1 carry flag will come here. So that's rotate with the carry flag. So you have the RCL, so that's why you have the RCR. So they are the same thing, just instead they go to the right, instead they go to the left earlier, they go to the right. So that's why when you go to the right, is your least significant bit will copy over to the carry flag. So the carry flag will be included into your rotation. So then they will copy over to the most significant bit. So you can decide how you want to do. So here, if we want to make the carry flag equal to 1, we do the STC. So that means set carry flag. So that's why here, when you do the move, you have AH is 1, 0, right? So that's in the binary number. So your carry flag is 1. But if we do the RCR, we are rotate to the right, right? Okay, so that's why here, your carry flag from here, they go here. Okay, so everyone go to the right. So this one, the last 0, will come to the new carry flag. So that's the rotation.